Okay, this short video is just a quick explanation as to why hydrogen bonds have such strong or are such strong intermolecular forces. We may not have a chance to really cover this very much in class, and I want to make sure that I don't just say things. I'd really like to explain a little bit more. So this video is an attempt to give you an explanation. Why are these dipoles so incredibly strong? First thing I want to say is don't mistake hydrogen bonding to be like covalent bonding or ionic bonding. I mean, it's fundamentally different. Hydrogen bonds are intermolecular forces. They are forces between molecules. They are not bonds within molecules. Okay? So they're not covalent molecular bonds. They're not ionic bonds. Hydrogen bonds are just an especially strong kind of a dipole. All right, why would that be? All right, so here it comes. So remember, hydrogen bonding happens when a molecule has a fluorine-hydrogen bond, a nitrogen-hydrogen bond, and an oxygen-hydrogen bond. Okay? Remember that, and if you look at the periodic table, you would agree that fluorine has the highest of all electronegativities. Next comes oxygen, and then next comes nitrogen. Okay? There's a very high electronegativity, what that means is electrons are pulled strongly toward that element. So like with fluorine, if you have hydrogen fluoride, all right, the hydrogen is losing its electrons within that bond toward fluorine. Fluorine is pulling on these electrons very strongly. Oxygen, which is the next highest electronegativity, is also pulling very strongly on that hydrogen. It's pulling those electrons away from hydrogen. Okay? And the same happens with nitrogen to a somewhat lesser extent. The biggies are fluorine and oxygen. And these, with nitrogen and oxygen, these are the hydrogen bonds that are going to be most important in biology. Okay, I'm going to draw a little diagram. I'm going to focus on oxygen and hydrogen in this next diagram. Okay, so here's my attempt to try to explain to you why hydrogen bonding is so strong. Okay, so I've drawn on this on the left side of the diagram an oxygen atom. Okay, it's got 8 protons, and these are the electrons. 1, 2, 3, 4, 5, 6 valence electrons, and 2 core electrons. That's 8 electrons. Here is the one hydrogen electron, right? And this is the nucleus of the hydrogen atom. It's just a proton, right? 1 proton. Here we have 8 protons for oxygen, okay? All right, now, oxygen has a very high electronegativity. It's got a very strong attraction for this electron from hydrogen, okay? Now, remember that electrons, this is the modern view of atoms, all right? Electrons really exist around atoms as clouds. So if you imagine these 2 electrons here, which are involved in the covalent bond, these 2 electrons are pulled more toward the oxygen than the hydrogen. What I want you to see here is if oxygen is stripping the electrons away from hydrogen, you are kind of left with a naked or a semi-naked proton. Okay? It's a proton that practically has its electrons pulled away from it. This is almost a full positive charge. Not quite, but it's a very strong positive side to this negative side. Okay? That partial positive charge is a very strong partial positive charge because of that naked proton there. Okay? And if that naked proton, I keep saying naked proton just to, it sounds a little bit, whatever, maybe a little weird. But I want you to see how that would result in a very strong attraction for this negative side here on that water, and there's a positive side to that water. Okay, this is a hydrogen bond, and it comes about because of this almost completely exposed proton in this molecule. Anyway, that's a little bit more detail that I think might be helpful to you. Anyway, hope that was fun, and I'll see you in class.